Welcome to Think Smart, and today's video we're looking at Science Paper 1 2018 Grade 12 Section B, Question B3. And this question is based on mass, weight, kinetic energy, and gravitational potential energy. Okay, so to go straight into the question there says figure B3.1 below shows an aeroplane flying at 120 meters above the ground. A box of mass 1.2 kg is seen falling off the aeroplane. Okay, so as we've been told there that we have a box there of mass 1.2 kg. So the box is there and it's seen falling off the aeroplane at a height of 120 meters. So that's the height. Okay, so A there reads, calculate the weight of the box. Calculate the weight of the box, and we've been told to take G representing the strength of gravity, to be 10 Newton per kg. So we know that weight equals mass times the strength of gravity. Mass times the strength of gravity. And as you calculate the weight of an object, make sure that your mass is always in kg. Make sure that your mass is always in kg whenever you're calculating for the weight. And the mass of the box here is 1.2 kg, as you can see. So the mass is already in kg. So we have 1.2 kg multiplied by the strength of gravity on Earth. We've been told to use 10 Newton per kg. 10 Newton per kg. So what will happen to the kgs there is that they will cancel out and will remain with newtons. So 1.2 times 10 gives us 12 newtons. So that is the weight of the box. Remember, each time you're asked to calculate the weight, your mass should always be in kg. If you are given mass in grams, convert to kg, and remember that 1 kg is equivalent to 1000 grams. So if you have to convert, you can use that relationship. But for this question, our mass was already given in kgs, so there was no need for us to convert. Okay, let's proceed to B. What will be the kinetic energy of the box just before it hits the ground? So the question there says, just before it hits the ground, what will be the kinetic energy? So we have learned about the principle of conservation of energy. Energy can neither be created or destroyed, but it can only be transferred from one form to another form. So in this case, the box of 1.2 kg, it's falling to the ground. It's falling to the ground at a height of 120 meters. So at this point, at this height of 120 meters, what we should know is that the box has a gravitational potential energy. At a height of 120 meters, the box has gravitational potential energy. Now, as the box starts to fall to the ground, just before it hits the ground, all the gravitational potential energy would have been converted to kinetic energy. So that's where we can see how energy is transformed from gravitational potential energy to kinetic energy. So first of all, for us to solve this question, as you can see, this question here is 3 marks. So it requires us to understand that the principle of conservation of energy. Energy can neither be created or destroyed, but it can only be converted, transferred to other forms of energies. So at the height of 120 newtons, the box has gravitational potential energy. As it starts to fall, it loses the gravitational potential. Loses gravitational potential energy, which is converted to kinetic energy. So we need to know what is the gravitational potential energy at the height of 20 meters. So first of all, gravitational potential energy is calculated by mass times strength of gravity times the height. Our height there was 1.2. Our mass was 1.2 kg. 1.2 kg. And the strength of gravity we're taught to use 10 Newton per kg. We multiply that by the height. Our height is 120 meters. Okay. And as you can see from the equation there, we have mg. Mg there simply gives us the weight that we calculated in air. So we're going to have 1.2 times 10, that gives us 20 newtons. Remember the kgs will cancel out. So 1.2 times 10 gives us 12 kg, multiplied now by the height, which is 120 meters. So that will give us 12 multiplied by 120. 12 times 120 meters, that gives us 1,440 Newton meter, or we can say, since it's energy, 1,440 joules. So this is the gravitational potential energy at a height of 120 meters. So now we are saying that when the box starts to fall to the ground, all this gravitational potential energy will be converted to kinetic energy, because kinetic energy there depends on the speed and the mass. So the principle there is that loss in gravitational potential energy is equal to gain in kinetic energy. Loss in gravitational potential energy equals gain in kinetic energy. So how much gravitational potential energy was lost? 1,440 440 joules. All this was converted to kinetic energy. So our kinetic energy just before hitting the ground is 1440 joules. Okay, so what do we need to take home? Remember, for us to calculate the weight, our mass should always be in kgs. If you are given mass in grams, you can use this relationship. 1 kg is equivalent to 1000 grams. And for B, when you're asked to calculate the kinetic energy of an object, just before it hits the ground, slightly just before it hits the ground, just know that loss in gravitational potential energy is equal to gain in kinetic energy just before hitting the ground. Okay, so that's all for today's video. Look out for more videos. Thank you.